Okay, so here's page 121, number 41. I kind of just draw out the problem here. We have a 6 kilogram box and it's sliding across a horizontal floor of an elevator. They give us the coefficient of kinetic friction, which is 3.60. They give us the mass of the box, and that's about it. And it's split into two parts. Or what they want us to do is they want us to find the kinetic frictional force when it's stationary for part B. So for part A, it's stationary. Stationary means the elevator is not moving, which means its acceleration is going to be 0. So if we look at our box, our 6 kilogram box, in this scenario, we have our force of gravity pushing down. We have our normal force pushing up because it's on the floor of an elevator. And because the acceleration is 0, we know that the net force in the y is going to be mass times acceleration. And this mass times acceleration is going to be 0 because it's not moving, and therefore the forces of the normal force minus the force of gravity have to cancel each other out. Now the force of gravity is just mass times gravity, so it's the normal force, and the force of gravity here is going to be 6 times 9.81, which gives us 58.86. So it's minus 58.86, which means our normal force is going to be equal to positive 58.86 newtons is our normal force. Now, why do we need our normal force? The reason we need our normal force is because the equation for friction, which is what we're trying to find in this case, the force of friction is equal to the coefficient, which is the kinetic because it's moving, times the normal force. So basically we just plug in 0.360 times 58.86, and that gives us 21.19 newtons is our frictional force when it is stationary. Now for part B, we're actually going to have an upward acceleration of 1.20 . So our net force in the y direction is going to be our mass times acceleration in y. Unlike before, this time we're not going to end up being 0 because we actually do have an acceleration. It's still going to equal our normal force minus our force of gravity. Our force of gravity is still going to stay 58.86 because the force of the mass didn't change, and force of gravity is mass times gravity, so we don't have to change that. So our equation becomes 6 times 1.20 equals the normal force minus 58.86. We end up with 7.2 newtons is equal to the normal force minus 58.86 newtons. We add 58.86 to both sides and we get 66.06 newtons is equal to the normal force. Now keep in mind that this stayed positive simply because this is pointing up. If it had been pointing down, we would have had to change our net force to a negative number. So now that we have the net force, we can find our force of kinetic friction by the same way we did before. The force of kinetic friction is still the coefficient times the normal force Our coefficient is still, I gotta go back and look, 0.360. And this time our normal force is going to be 66.06 newtons. So that ends up being 23.78 newtons. So we have part A and part B. Our frictional force for part B is going to be greater because our normal force is bigger. And our normal, it makes sense because when you're going up on an elevator, you feel like you're going to kind of getting a little compressed. Okay, now we do part C. For part C, we now, let's see if we look back, accelerating down with an acceleration of 1.22. So now we're going down with an acceleration of 1.20. Now pay attention that it's going down, so our net force is going to be a negative. So our net force in the y, just like before, is going to be our mass times acceleration in the y, which is going to equal to our two forces in the y. Our two forces in the y are just simply the normal force pointing up minus the force of gravity. Our mass times acceleration in the y, so we're going to have 6 times negative 1.20. And that's going to equal our normal force minus the same force of gravity we've always had, 58.86, because that never changes. So we end up with negative 7.2 is equal to the normal force minus 58.86. So we end up with 51.66 newtons is the normal force. Now that we have our normal force, we can calculate our force of friction in this scenario. So our force of friction, I'll try another color, do with a little red or orange. Our force of friction is equal to the coefficient times our normal force. Our coefficient is still 0.360. Now our normal force is 51.66 newtons, right? We got it from there. So we get our force of friction, if this box was indeed moving, is 18.60 newtons. So there we have our A, B, and C for this particular problem.